In this video, we will be looking at slope and different ways you can calculate it. So first of all, slope refers to how steep a line is. The steeper the line, the larger the slope. And the more shallow the line, the smaller the slope. So if you think about a mountain versus a hill, a mountain might be a lot steeper than a hill, so the slope of the mountain is going to be larger than the slope of the hill. Now, the main formula you saw in grade 9 related to slope was that m, which is the notation we use for slope, is equal to rise over run. So if you look at the little diagram on the right, you have a line here. And in order to calculate the slope, we create a rate triangle. So you pretty much just pick 2 points on your line and create a triangle out of them. So you draw a horizontal line, you draw a vertical line, and your triangle is created. Now, the vertical line is going to represent your rise, and the horizontal represents the run. So when you do calculate the slope using this visual method, you do have to be very careful that you count the vertical line first, because rise is always going to be on top. It is rise over run, not run over rise. So let's try it out in our first example of a ramp and a set of stairs. So on this ramp, the rise is going to be the 2 feet and the run is going to be the 12 feet. So using proper notation, m equals rise, so 2, over run, which is 12. Now the only thing you have to do here is look at your fraction and see if you can simplify it further, which we can. Both the 2 and the 12 are divisible by 2. So if I divide top and bottom by 2, I end up with 1 over 6 for my slope. Let's try it again for the staircase. So once again, the rise is going to be the 10 because it's the vertical. The 18 is the run. So our slope will be rise 10 over run 18. And again, let's reduce this. Both the 10 and the 18 can be divided by 2. So 10 divided by 2 is 5, 18 divided by 2 is 9. So there's the slope of the staircase. And if I were to compare the stairs and this ramp, the slope of the stairs, the 5 over 9, is larger than the 1 over 6, so I can say that the stairs are steeper than the ramp. Now let's try some more examples, but this time I'm going to give you some coordinates to create a line segment. That way we practice plotting points, and then we'll apply our rise over run. All right, so for line A, we have -4, 2. So -4 on the x-axis is here because x always comes first, and then we go up to 2 on the y-axis. So here's our coordinate. And then we have 5, 6. 5 is right here on the x-axis, and I climb up to 6. So here's my coordinate. Now I'll draw a line to connect my points. I will label this line A. And now you just draw your triangle. Now I'm just going to start from this bottom point, and I'll draw my horizontal line across and then vertical up to reach my point. You could have also drawn your rate triangle above the line. That would have been perfectly fine. And now let's count. Remember, rise comes first, so I'll count that first. 1, 2, 3, 4 for the rise. 1, 2, 3, 4, 5, 6, 7, 8, 9 for the run. So when we put that together, rise over run, it's going to be 4 over 9 for line A. Let's go ahead to line B. So for line B, we are at -8 on the x-axis, and we go down for -2 on the y-axis. And then we have -2 on the x-axis going down to -4. Now notice when we connect these points, our line is going downwards. When your line goes down, your slope is going to be negative. So I'll make a little note here. Negative because it's going down. Now let's create that triangle. Notice when I create my triangle, if I pick the point on the left, I'm going down to draw my rise. So when I count 1, 2, that's -2 for the rise, 1, 2, 3, 4, 5, 6 for the run. So my slope is -2 over 6. And if I reduce my fraction by dividing top and bottom by 2, I get -1 over 3 for my slope. All right, for line C, we are at 1, 8. So 1 on the x-axis and then climb up to 8. And then 6, 8. Now notice here when I connect my dots, we have a horizontal line. If I try to count my rise, I can't even draw a triangle here. So there is no rising, so the rise is 0. My run, however, if I count, is 5. So when I do my slope, rise of 0, run of 5, 0 divided by anything, not just 0 divided by 5, 0 divided by anything is 0. And I do expect you to reduce it to 0. All right, so how about you pause the video here and try to plot the coordinates for line D, find the slope, and then come back to check your work. All right, so 0, -2 is here, and then 2, -8 is here. This is again one of those scenarios where when I plot my points, I do get a negative line for line D. So I'm gonna draw my triangle here. From my top point, I go down and then to the right. 1, 2, 3, 4, 5, 6 down, and 1, 2 to the right. So when you put your slope, hopefully you put -6 over 2. And in this scenario, this fraction actually reduces to a nice whole number of -3. You could also write -3 over 1, but if you can get rid of the fraction, why not do it? All right, now see if you went wrong somewhere, take a note of it, and again, pause the video and try line E for our final rise over run. All right, so -6, 6 is right here. 2, 10 is way up here. I connect my points and I see that the line is going upwards, so I know the slope will be positive. Here I am drawing my triangle, and when I count 4 for the rise, 4 for the run, so our slope 4 over 4, which is just 1. And that's it. So this is us using the visual to find our slope by doing rise over run and drawing that right triangle. Now, if you don't have a graph and you just have the coordinates, you can also find the slope in an algebraic way by plugging them into this formula. And our formula is y2 minus y1 over x2 minus x1. This y2, y1, x2, x1, these are just the coordinates. When you get two coordinates, you can label them. Coordinate 1 will be x1, y1. Coordinate 2, x2, y2. Each coordinate should have an x and a y, and their numbers should match. And then you literally just plug into your formula. Now, when you subtract your y's, you actually end up getting your rise because y's are vertical and the rise is vertical. Likewise, when you subtract your x's, you get your run because the x's are the horizontal part, which is the run. So let's try it out. Step 1, organize yourself, label your coordinates. So I'm going to say this is x1, y1, x2, y2. And now let's go to our formula. So the formula says y2 minus y1, so -4, subtract 4. And then x2 minus x1, so 2 subtract -4. And now we just clean up the numerator. So be careful with your signs here. -4 minus 4 is -8. 2 subtract -4, those two negatives actually become positive, so it becomes 2 plus 4, which is 6. And then we can reduce our fraction. -8 and +6, they can be divided by 2 to get -4 over 3 as our final slope. Let's try it again. Step 1, label x1, y1, x2, y2. It doesn't matter what you number them. You could have said the first set of points was the 2, x2, y2, and the other one was x1, y1. It really doesn't matter as long as you're consistent. So y2 minus y1, so negative 3, subtract the 2, over x2, which is 0, subtract x1, which is negative 1. Be careful, again, we have those double negatives. We're subtracting the negative. So negative 3 subtract 2 is negative 5. 0 plus 1 is 1. And I will reduce that to the nice whole number of negative 5. So why don't you pause the video here, try using the slope formula for line C, and then come back to check your work. Okay, so first thing, hopefully you labeled. It's just good for your organization and not to make a silly mistake. So y2 subtract y1, which is 8, x2, 4, subtract x1, 0. Clean up. Careful here, don't do 2 minus 8. Make sure you did negative 2 minus 8, which is negative 10, and 4 minus 0 is 4. Both of these numbers can be divided by 2, so we get negative 5 over 2. Now, if you went wrong, learn from that mistake, take a note of it, apply this new knowledge to line D. Again, pause the video, try it out, and then come back to check your work. So there's the labeling. y2, 7, subtract y1, negative 3, over x2, 6, subtract x1, 2. 7 subtract negative 3 becomes 7 plus 3, which is 10. 6 subtract 2 is 4. This again is divisible by 2. So 5, positive 5 over 2 is your answer. So this is finding the slope from a set of coordinates without the graph. Now, if you are given a set of coordinates, you would be given the choice to use the graph or use the formula. Depends on your preference. Let's move on to what happens if you have a table of values. Well, first of all, a table of values is just a bunch of coordinates. So really, you can pick two sets of the coordinates and do the slope formula that we just did, y2 minus y1 over x2 minus x1. That can take a little bit longer. So we know that slope is rise over run. Rise is the difference in your y values. And we also know that from the formula we just did. And run is the difference in your x values. So really, just pick two coordinates, whichever two coordinates make you happy, and find the difference in the values. Now, when you pick your coordinates, I like to pick ones where I just have positive numbers. So I'm just going to pick these bottom two. And I want to find the difference in the y's, because y is rise. Now, whenever you find the difference, I always want you to do bottom subtract top. So 7 subtract 4 is 3. So my rise is 3. My run is for my x. Bottom is 4. 4 minus 3 is 1. Now, let's just put that together. Slope is rise 3 over run 1. That's just 3. Okay? So as the y's increased by 3, the run increased by 1. And that's exactly what our slope shows us. Let's try the next one. So I'll take this middle set of values. Again, trying to avoid the negative so I don't make silly mistakes. So bottom minus top. 4 subtract 8 is negative 4. So that means my y values are decreasing by 4. And for my x's, 2 subtract 0 is 2. So as the x's increase by 2, the y's drop by negative 4. So here's the rise, which is really dropping, and here's the run. And when we put it together, negative 4 over 2, this does reduce to negative 2, or negative 2 over 1 if you want, but if you can get a whole number, why not? All right, so there it is, 3 different ways to calculate the slope. From a graph, from a visual, rise over run. Rise is the vertical, run is the horizontal. From 2 set of points, use the slope formula. y2 minus y1, x2 minus x1. Be careful with your labeling, be careful with your signs. From a table of values, just pick 2 sets of coordinates and subtract the y's, subtract the x's, remembering bottom minus top. And that's it, rise over run, 3 different ways.